Hello scientists, Mrs. Deming. I'm going to make a little helper video that goes along with this assignment. It's helping us figure out how do we read the relationship on a bar graph. We did decide that a bar graph is the best way to show the data in our marble experiment, where we're answering the question, which is shown right here. The question is, how does the mass of the marble affect the distance it traveled down a ramp? Here I'm going to show you three different possible graphs that you may make with your data, and then we're going to discuss what the graph shows as far as the relationship between our two variables of marble mass and distance traveled. So this first one, if you notice, this is how your graph should be set up on your experiment that we were doing. So if you notice, it goes plastic, glass, metal, and then underneath I have the masses that I came up with, 0.9, 2.1, 8.8, and then I have listed here the independent variable. We had discussed before that mass should be the independent variable, and we've slightly changed that to marble type because we are using a bar graph. It does go together, mass and marble type, so that makes sense. On our dependent, or the y-axis over here, remember dry mix, dependent on the y, mix manipulated independent on the x. So our dependent goes over here, distance traveled in centimeters. I put this little zigzag because we're not starting at 0. I started at 20 and I went to 30 because all of my averages were between 20 and 30. If my average was 17, then I'd have to start like 15 to 30. So you want to have a spread of numbers here that reflects the data that you have. Okay, then I drew a box, a bar, to show the height of the bar shows how far the average distance traveled by the plastic marbles, the average distance traveled by the glass, the average distance traveled by the metal. Then we want to look at this. We see that as the mass increases out here, because that's the way we've put them on the axis, as the mass increases out the y-axis, so we want to put as the mass of the marble increases, the distance it travels, in this graph, the bars are getting bigger as we go up in mass, also increases. Okay, I'm just abbreviating with INC. This next graph, the sentence is not written there for you, but you want to do the same thing. So this sentence that we just wrote is telling us the relationship between those variables. So in this one, you want to write a sentence that says, we have them still, the plastic, the glass, and the metal. So the mass is still increasing. So you'd say as the mass increases, but this time the bars are going down, showing us that our distance traveled is decreasing. So this sentence would be as the mass of the marble increases, the distance it traveled decreases. So you're writing the same sentence, but you're saying increase and decrease for number 2. And then the last one here, we have them still in order by mass, but this time the bars don't show any clear pattern. So this third one says, hint, this one is not like the others, because here we don't see that there's clearly a relationship in either direction. We say as the mass increases, we do not see that there is a relationship to the distance traveled. So no relationship is shown in this set of data. We'd want to test many times, maybe more times. This is actually what a lot of people in class got, and it really shouldn't be. The metal should have gone the farthest, the glass should have kind of went in between, and the plastic just went, should have the shortest bar. But that's not what everybody saw. Maybe we need to do more trials. So for this assignment, you need to type in those 3 sentences like we just discussed, and then submit it. And then use this as a guide to make the graph for our marble and distance traveled activity on the large piece of paper. You have a copy of it in Kami from a few days ago. So there is that one, you guys. Oh, the only other relationship that we don't have shown here is if we had the plastic, the glass, and the metal in the same order and all the bars were the same length. So we would show that there's no increase or decrease. So really it could be increase, decrease, or remain the same. So as the mass of the marble increases, the distance it travels remains the same. That would also be another way that we really wouldn't see that there's a relationship. Thanks for joining me. Make sure you get that submitted.